that's where that likelihood would be driven by that data. And then you can see, right, if you do it at those steps, and that doesn't mean monitor every step, but I'm just saying internal data should drive, when you get to your processing steps, it should drive what you see. It doesn't mean that you don't take into account that, some competitor has had a recall and you guys make the same product. Okay, well, then it could happen, right? It could happen. But it still should be driven by your internal data. What you see, what risk do you face? And you should define it that way, right?
Welcome to the Feed Science Podcast. I'm Ron Hollenbach. We're going to discuss feed and food safety today. Our guest is Scott Hawks from Hawks Strategies. Welcome, Scott.
Thank you. Thank you very much. Thank you for inviting me.
Mm-hmm. Well, Scott, if you'd start out, just kind of give a little background on yourself, your company, just to give the audience a little bit of background and understanding of your experiences and where you come from.
Okay. Yeah. I'm originally from Michigan. I went to Michigan State University and studied food science. I'm a protein chemist and microbiologist by training. And I liked research. I did some research at Purdue University, at Cornell University, and various topics, but mostly protein technology. And then I, at Cornell, ended up working in their pilot plant, which worked with local New York State industry, mostly companies that were smaller companies. Didn't have a lot of resources, so we were sort of an extension for them to help them bring their products to market. But also, we worked with much larger companies, anything in the top 100 food companies. We helped develop pilot scale products, which was my foray into food safety, because in order to, like, if you want to make a certain amount of yogurt for a food safety, demonstration, or if you want to take a flavor and put it into a product and take it to a trade show and pass it out, you have to have a HACCP certification. So that was really my first foray into, okay, it's not just making unique products, but how do you do it so that people don't get sick but at the same time have a process that's doable. And so after that, I worked for a company called Covance Laboratories, which is now, they've been purchased by Eurofins, but it was Covance at the time. They did a lot of food chemistry and microbiology to support label claims, and also when people had issues with products, right? You do a lot of testing. And I was in technical sales for them. So I ended up helping clients more, rather than sell, it was more helping root cause analysis, and also how to design studies to gather data in some type of cost-effective way where you can get your answers, but it doesn't cost you $250,000 to do it. So that was fun. With Covance, I was sent over to Singapore to build a nutrition laboratory and a micro lab in Singapore. So that was, in 2007. I was going to do that and come back in a couple of years, but I met some folks from Nestle and stayed another 4 years and worked for Nestle implementing ISO 22000 standards in the various production facilities, R&D facilities, supporting that region and supporting the R&D center in Singapore. So learned a lot there. Came back to the U.S. and ended up working for a pet food company, Wellness, and implementing right at now we're up to around 2011 implementing FSMA standards because now they rolled out and in the pet food in their kibble facility. And so did that over 4 years. Great learnings. That was very interesting to work in that industry. And then I went to work for Tata Global Beverages. They own Tetley Tea, 8 O'Clock Coffee, some other brands, implementing the FSMA standards on the food side. So there was some big learnings because it was coffee and tea. It's a little different food category than some of the ready to eat things that you do. And then after that, I met some folks from Tox Strategies, and they said, would you come work for us? So I ventured out into consulting, and that's where I'm a senior consultant for food safety and regulatory affairs. So that's sort of a long story of how I ended up here.
Sure. Well, good. Thank you.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
As we think about feed and food safety, I mean, that's a huge topic. We're obviously in the time frame of this podcast where we won't cover everything. We'll just barely scratch the surface in this discussion. But as it comes to feed and food safety, what's a critical component of creating a quality food safety plan as well as meeting all the FSMA requirements. I mean, I know there's a long list of things that need to be covered, but what, in your mind, what are the maybe the most the one or two most important that we could actually discuss and do justice in the length of this podcast?
Yep. I think it's approaching, no matter any manufacturing. So right now we're talking feed and food, but I don't care if you're making chairs or cars. You have to approach it with the attitude of you are the master of your product and your process, right? So I get that it's nerve-wracking when FDA or third-party auditor comes into your facility. There's always, that's always a sort of a tension there. But at the end of the day, if I'm in my plant, you will not come in and tell me how I operate. I will tell you how I operate because I've asked the questions. Is what I'm making safe? Is what I'm making compliant? Is what I'm making support the quality and stability of the product? And I have a lot of people there that have also, day to day, in and out, they deal with those problems that come up. And so they really are, it's not from a position of arrogance, it's a position of, well, we make the product. So we are the masters of how to do it. But the most important thing that anybody in this field, which is a science field, can do is ask the right question. So we talk about experts, right? And I know I get paid to be one. But the most important thing is that you ask the right question. If I ask the right question, I will get 10 people that can answer it. And it might be the guy on the third shift extruder machine. It might be an outside consultant, a microbiologist. But if I ask the wrong question, everybody's effort is directed at the wrong things. So that's asking those right questions is how you develop your food safety plan. the most important thing about a food safety plan, and you can kind of see it, and this is also any other part of FSMA, is that you do your hazard analysis correctly. So I don't think we can get GMP is its own foundation. And we'll just say that sanitation, which is the cornerstone of everything, cleaning, housekeeping, sanitation, you have to get that right. And there's a whole, right, we could spend an hour talking about that. But for GMPs, get the sanitation correct, meaning doing the right things at the right time and verifying that they're working. But for FSMA, hazard analysis, risk assessment is something that I just see it day in and day out. It isn't that people don't know their operation. It's that they know their operation so well, it's like a pilot flying a plane that's running smoothly. There's not much to do. It's going well. But risk assessment is about asking those questions, right? So the first one is, because preventive control is always a confusing thing to people. Is it a preventive control? Is it not? The first question to ask is, what if I did nothing? What if I didn't do anything? And by that, I mean, what if I take my raw material and I just make the product and I don't have any controls, right? And I put it out on the market? What would happen? So if your answer to that is, I wouldn't want to do that because somebody's going to get sick, there's probably a preventive control. Or in feed, I wouldn't want to do that. Animals are going to die. There's probably a preventive control in there somewhere, right? But as a first question, you make it simple. Now, it isn't always, because some people might say, well, Scott, if I ask that question, every food's going to have preventive control. That's not true. So think of coffee. What if I took green coffee and for people, right? So you take the green coffee beans, you roast them at a high temperature, and you put them in a bag, right? You grind them, and people either make cold brew coffee or they make hot brew. But if I didn't do anything other than my process, run it through that process, no one would be harmed by coffee. Nobody has been. Now, you can get into flavored coffees and you get into allergens, right? There's been recalls and things. So that's always, but in general, that's a very safe product, but that question still holds. Like, what if I didn't do anything? Okay, well, probably nothing. Now, what people will say is, well, so you're saying, Scott, no controls. But that's not true either, right? GMP is control, right? When I clean, it's a control. So that's where I think people get confused about preventive control. If you probably remember when HACCP first came out, everything was a critical control point because nobody wanted to miss it. And then we got more sophisticated and said, that's actually not, it's this step. Preventive controls are like that, where you want to have a decision tree asking questions like, similar to HACCP, is there a hazard? Is it significant? Does this step eliminate it, reduce it? But it's applying that to things like cleaning a piece of equipment as opposed to pasteurizing some product, right? So it's much more broad. But it's those questions that help you do hazard analysis rather than being an answer type society where it's like, no, Scott, that's not a problem because we have this. Well, then now you're getting ahead of yourself and you won't do the risk assessment properly.
And when HACCP came out, or at least my experience as we were going through the hazard analysis in feed mills, my mind was around, a preventive control was I'll call like more of an engineering control. You were trying to, how do we engineer out that potential hazard, just like you would from OSHA and other safety type items. And so we ended up, heck, everything had a whole list of controls, and everything was a critical control point because we weren't thinking about it correctly when we went down that path, and ended up having to back up and do it again. But we learned from it, but it was painful and to some extent intimidating, I guess, at the time. But after we worked through the process and actually got the food safety plan in place, for the most part, it's really pretty common sense. It's stuff we should have been doing anyway. And in most cases we were, but there were some areas that, we weren't thinking about it and it slipped through the cracks.
Yeah. Yes. It's you want to make it expansive. So one of the more common failures in a plan is people do not identify all the potential hazards. And some of it is because we tend to have an operation mindset, right? So if I say, well, you're bringing salmonella in with the chicken meal to make so that's a hazard. No, Scott, we control that. It goes through the extruder. But when you're doing the hazard analysis, like, no, first we're going to identify all the potential hazards. We'll get to are they significant later, and then what controls. And so it's very easy, like you had said, it can drive you crazy because you have to compartmentalize and say, okay, what are all the hazards? All right, now I have the hazards that are associated with the ingredients, with the process steps. And then I get into what is the likelihood. And likelihood is probably the most common failure I see, because the probability, and that's difficult. One is what I talked about. People assess likelihood and say, well, it's not going to happen. We have controls. But likelihood is to be determined without controls. It goes back to that question, what if I did nothing? And so that first step is, okay, if I didn't have any controls, what's the probability this hazard would go out and cause some significant, right? And so that people are a little nervous to do that, because then they think, oh my God, well, then everything's going to be a hazard. But of course it's not, because you can also check and see if in your food category, do I find salmonella out there in recalls, in import alerts? Have there been withdrawals, warning letters? Is this a problem in the category that I'm in? And sometimes it's not. And then you have to dig a little deeper and say, why is that? Right? Some of it could be controls, but some of it is there's a natural association of certain hazards with certain products. And so it's that. But one of the biggest is that people do likelihood with the idea of control in mind. And really, first, you have to look and say, what is the likelihood that this hazard's going to get out there without those controls? And then we can go and look at how we mitigate it. The biggest mistake I see in severity, which is the other portion of the equation, is people also get it mixed with control. And they'll pick salmonella, and it should be the highest severity because it can cause death. But for pets, say aflatoxin, right? It'll kill pets. That severity through your entire hazard analysis does not change. But people will sort of get confused and say, oh, well, this mitigates and therefore it's less severe. And so you'll go down and say, well, why did the severity of aflatoxin change? Right? So that is, you really have to think about that. And target animal matters, right? If I were talking about aflatoxin for pets, but then there was some other target animal where there was never an outcome and it didn't pass through to humans, all right, well, I probably have to look and justify maybe a lower severity for that. But once you pick it and base it on that, it doesn't change, or at least I have not seen a situation where somebody could explain why it changed in your hazard analysis. So those are just to cover those.
Yeah, and that makes sense to me, the severity. That part I didn't struggle with, because I don't know why that one makes sense, that it's either severe or it's not. And hopefully the controls that are in place later make it so it's not a hazard. But I struggled very much with the initial likelihood. I instantly, my mind went through the process, the final product going out, and okay, it's not likely that's going to happen. Well, yeah, that process didn't work. I mean, when we got to the end, and when you actually identified all of the preventive controls, then after all the preventive controls, certainly the likelihood decreased. But I understand how you need to approach it in the beginning. But I know for me personally, I jumped to the end with what I thought the likelihood would be, and of course that created more rework because we did it wrong.
Yeah, it's a hard, and there's two different approaches. So when we're talking about what's inherent in an ingredient, we can go to those databases, right? FDA's warning letters and import alerts and recalls, and we can kind of get an idea, this ingredient has a high number of recalls associated with this. Okay, well, the likelihood then is high. When we get to processing steps, though, that method, although it's still in my mind because it is being made by a plant that's handling that ingredient, and so it's in there somewhere. But that's where the internal data is much more valuable. So, and my biggest learning was actually arguing with plant managers, where I would say, well, that's pretty high likelihood, and they're like, show me, prove that to me. And so then you start gathering data and saying, we actually have never seen this in our receiving. It's never showed up, and we test for it every lot. So that's where that likelihood would be driven by that data. And then you can see, right, if you do it at those steps, and that doesn't mean monitor every step, but I'm just saying internal data should drive, when you get to your processing steps, it should drive what you see. It doesn't mean that you don't take into account that, some competitor has had a recall and you guys make the same product. Okay, well, then it could happen, right? It could happen, but it still should be driven by your internal data. What you see, what risk do you face? And you should define it that way, right? So I might say for an ingredient, this has never been seen in that ingredient in the whole that I can find in the history of these databases. That would be a low risk rating. This happens every 2 weeks in the warning letters. It's always in there. All right, well, that's a high likelihood for that ingredient. For your processing step, same thing. We haven't seen it in the history of our company at this step. And then that would be low. Or for some things, yeah, of course, it's in every lot. Like if I'm receiving chicken meal, yep, if I test it, I know it's going to be there. Okay, well, that's a high likelihood for that receiving step that you see it there. It's an example, but when you get to process, let some of the data that you've spent the money collecting drive your likelihood. And then you can kind of see that's where, when you are talking to auditors, you are the master. you have a reason why you rated it that way. It wasn't just because you were uncomfortable with giving it a high rating. It's like, we know this is something that has to be controlled, or we also know we don't want to waste our resources on this step because we want to control the ones that actually are the big risk, right? Because some people will pull resources away and try to cover everything, but you really want your resources dedicated to those things where you found a significant risk.
Mm-hmm. And you said early on, it's the most critical or important thing to do is ask the right questions. So as you go into a facility, and like the one you just referenced where you were talking with the plant manager, and they said, that we don't have that problem, prove it to me. How do you lead those people to ask the right questions, to understand it and get it right without beating them over the head and telling them, you're wrong? I mean, how do you lead them to that?
Yeah, you never want to, right? Because the first thing is, I don't know that they're wrong, right? But they don't know they're right. So I usually make it, because it's money to spend. So if you say prove it, it's like, okay, I can prove it, but I'll have to do some testing, some looking, some inspecting, and that costs money and time. But they do understand. It's like, it is about probabilities. So I use the chicken meal example again. If I go test that chicken meal, I'm going to find salmonella. And the probability that I was going to find it through testing is very low. So if I get a hit, it's there. It's there because I was never going to find it. So that's something about testing. People put a little bit too much false hope in testing. If I don't find it, it doesn't mean it's not there. But if I find it, it's a pretty systemic thing because the probability that I was ever going to find it by taking a sample and testing it is very low. That's why FDA, right, when they react to something they found in the marketplace that tested positive, there's 8 people at that plant because they know like, this is not the probability that we were going to pull a package off a shelf, test it, and find any kind of hazard that's not homogeneously distributed through the product was 0. So we found it. That means there's a significant problem at that facility. And that's why they do. That's why they react the way they do. So if I don't have to do a lot of testing if I think it's high, and it's really, not a problem at all, I'll find it. It'll show up. And then if it does, it's a big problem because I wasn't really gonna find that. So it's an example of that. That might be how I say we can do this with a small budget, but it's a question, not something just that I want answered. You want it answered because it's your business risk. And then we'll deal with the data pragmatically on what do we do, right? The answer in extrusion is we'll segregate it from the plant where we're making the stuff, right? People won't just walk through and then walk through the whole plant. I mean, there's already mitigation strategies for that. But always remember that the plant manager, the operations people, they have to balance 2 things. I think it's some of the hardest stuff to do. They have to balance profit, right, and output. And they're ruled by the sales revenue, right? So if sales go down, the pressure becomes more on operations. And I'm not telling you anything, but people might not know that. So always come humble with the question rather than this is what you need to do, or I'm the expert and I know. But if I pose that question and they say, prove it, it's like, well, I can't prove it. I'm asking it. I'm just saying, if you have an answer or your team does, let's go. I bet they do. I bet they do have an answer. A lot of times what you'll find out is there'll be a quality person saying, yeah, I know that's been a problem. I've brought it up, but that's how I think. Questions are, everybody likes to get it right. So they may react initially like not like it, but I think if you just put it in that way, we're just trying to get the answer so we can mitigate so that we can pragmatically manage a business risk. I don't want to dedicate resources to something that's not needed, but because you're talking about someone, animal or human, could be harmed, I don't want to leave that question unanswered, and most people don't want to leave that unanswered either. I don't know if that helps, but that's how I've always dealt. And I've always found that once you show that you understand that the operation, like we can't just follow everything. That's why I say the right question, not every question, the right questions, which requires some thought on whoever the expert is. That is the person that should really think about these things and pose them. And the rest of I've not seen it yet where when I posed the question, there was a maintenance person, there was an operations person, there was a quality person. And if none of those people could answer it, then you could go outside and they would do it. But many times it was the people on the floor making the product that said, oh, I didn't realize that was important. Well, you should look at this. And oh, I didn't know that. That's how you get it. And you approach that a few times, right? And having been in operations knows who's wasting their time and who's like, okay, I'll listen to what they say because last time they really helped us dodge a bullet, or they helped us gain some efficiency here, right? So that's the other thing. I've been in places where they were spending 12 hours cleaning a line that was complicated, and you looked at it, you're like, first of all, it's not cleanable. That part of your line, you're wasting your 12 hours. Here's how I think you should approach it, and take your time and put it elsewhere, where you can really mitigate a risk. And operations remembers that, right? Because they're like, well, you just saved us. That's 10 hours of downtime you saved us. And we thought we were mitigating a risk that we weren't. And
it's very, very true that certainly in a food safety plan, you've got to involve everybody. I've been involved with companies who early on, when FSMA first rolled out, the food safety plan was written at corporate and handed down and said, just modify this to fit your plant. Well, then it becomes one of those programs that, yep, you've checked the box, you have a binder, you have a book that sits on the shelf and collects dust. That doesn't work if you're going to be in compliance with FSMA. And it's amazing how many people, took that approach. And we hired a consultant to help us because, hell, I've proven with what I've said, I had no clue of what we were supposed to be doing. And that was the message he drove home every time he was there, that this has to be a living document. You have to live it. We don't do something because it is a food safety or a FSMA requirement. This is just how we conduct business now, and driving that culture into a plant it's not easy, and you really have to. It has to drive. I shouldn't say it has to drive what you do. It just becomes part of what you do, not something we do special because we have a third-party audit coming in, or we're expecting to, have the FDA come in or something and do a food safety audit. It becomes a culture.
Yeah, and honestly, I've been through quite a few FDA and state audits. I never had a problem with it. I got into an argument here and there, but with justification of data on why something was done. And guess what? Sometimes it was like, yeah, I still don't agree with you, and you would go. But ultimately, the difference was you came with data. There was a reason you were doing something. It wasn't just because they said, well, what about aflatoxin? And everybody's got a blank stare. Then, right. Or let me pull out a napkin. I wrote this down somewhere, right? If you come with, I am the master of my product and process. Here's how we do it. Like, I always tell people a food safety plan or the foreign supplier verification program, whatever it is, remember it's a presentation because yes, you understand it because you've been through it many times, but the person who you're presenting to hasn't. So set it up to walk them through step by step how you got to the place you got to. And I just rarely have had a problem where people didn't say, okay, and even when there was, they understood that you had a rationale based on something other than you just didn't want to do it or something like that. It was based on, I asked this question, I went and got some data, or I went and got some literature, and this is why we do it the way we do it. That goes a long way for an auditor, even if they don't agree with you. It will be a very different experience than if nobody's asked questions. And like you said, if you don't have your operations involved, so it's like one person knows this and the rest of the people are like, talk to so-and-so.
Yeah. It's pretty clear what, when you actually start talking to people, is it truly how you do business, or is it that book on the shelf that we pull out when you show up to audit us?
Yeah. And training comes into it too, right? After you get this set up, by talking to, so that maintenance understands their role. Like, this is the plan, but you guys, this is how you can look at things. Maybe, like you said, maybe there's a better way to design what we do so that we don't spend 10 hours cleaning. We design something that's either more cleanable, or we don't have to clean it at all because it was open to an environment. Now it's closed, right? So when you involve each person and say, here's the risk and here's your role in it, they will, most of the time, people are like, oh, I didn't know that. Well, when we do the handover, we really should do this first. They'll tell you most of the time. And it doesn't take that long. I'm not talking about a 3-day course. It's just, here's what's relevant for you in this plan. And I need your help because you have the expertise. I don't. And I've had a lot of, and that goes with operators. I mean, most of my knowledge has come from just talking to people that make the product. It's amazing what I have learned from them.
It's time for our famous 3.
Well, this has been an interesting conversation for me, but we probably should wrap this up. So let's. There's a few questions I'd like to ask at the end. What is your favorite feed or food science resource that you go to on a regular basis for information?
Yep, I have. So I have several books that I go to since we're talking about risk assessment. One is a HACCP book written, it's by Sarah Mortimer and Carol Wallace. Excellent book. I think it's on its 3rd edition. But it's that's something that anybody in that field, you should take a little time in your day to read something like that, right? So that you see how other people have approached this and taken the time to write it down. So, but that's a great book on HACCP, but it applies to any hazard analysis. There's the Food Microbiology edition 6, 7, 8. So you can go in there and find out about microorganisms and what kind of food products. It's really helpful on sampling. It's really helpful on specifications, microbiological specifications, because that's always confusing. It talks a little bit about testing. So it's a good sources. Those are probably the two that I use, the two sources that I use the most. There are others, but even mycotoxins in that food microbiology series, that they talk about mycotoxins, how to sample properly for mycotoxins and things like that. So I would say those are the books. The other one that's good for anybody, and I would highly recommend it for anybody in management, it's not a technical book, is the one Food Safety Culture by Frank Yanis. That's it's about 80 pages. It's very simple. I had an operational leader who read it and actually looked at our food auditing program and made it 100% more effective. Because he talks about behavior, like why do people do things that then cause food safety systems to fail. It's a great, but it's a very simple read. Food Safety Culture by Frank. So I would highly recommend that one too.
Okay. Well, the last question, I guess, is in your opinion, what people in the feed and food safety world, what characteristics or what would set somebody, the people who are the most successful, what would separate them from people who are, say, less successful in that industry?
Yep. Probably the same things, right, that make anybody successful. So there's dedication, you're right. You need a certain work ethic. In the food safety, although I would argue in anyone, the most important thing, first of all, is to be humble. The hardest thing for a subject matter expert or somebody technical is you know a lot. You have a lot of answers in your head, you know. But if you are a little bit more like, well, I don't know everything, you will go back to that, ask the right question, and let others that actually know a lot more about whatever operation you're going into, they know a lot more than you think they do. So if you approach it with that humbleness, I would say that's important because it will lead to that, ask the right question. You can get to the right answers later, but that would be that. The other thing is moral clarity. And what I mean by that, so there's three categories of risk: food safety risk, compliance risk, quality risk, right? That's our general. But the first question we should ask ourselves is, do I feel okay that something out there might harm somebody, an animal or a person, right? And the answer is probably no, I don't. But would I feel good if I didn't use my dedication and right questions such that I burdened my company so much that they went out of business and couldn't produce profitably, right? So it's that moral clarity of this is when you get to disposition of product, right, which you will get to a lot, and the decisions you make around that will either increase your influence with the business if you make good decisions, or, right, you've had the expert where it's like nobody wants to talk to you, and they don't. It's just a reality. I mean, human beings, that's how we interact. So be that person that understands the difference between, no, this can't go out the door because I understand that we can't harm people or animals, or I don't want to harm people or animals, but in this case, I believe we can manage it. We can protect people in them. So that may be a little out there, philosophical, but if you think about what's helped you in your career is that people can trust what you say. People have some faith that you also care about how they're measured and their success. And I don't know about you, but those people, they're like gold in an organization, and they're well respected. And I mean, from the CEO all the way down to the people on the floor of the plant, that person, you can always tell who it is. And it doesn't mean that they're yes people. They're respected because of this moral clarity where they're asking questions and they're interested. I don't want you to fail, and I don't want me to fail, and we don't want to harm anybody. So I hope that helps people. But, if young people want to know more about that, read about great people who were way better at it than I ever was in terms of leadership. And look at George Washington, Ben Franklin. Winston Churchill's a great one to read because he actually describes his thinking while he was making tough decisions. So read about great people, and you can learn a lot about how you should comport yourself, because at the end of the day, you're either working together and you'll be successful, or you'll be this person who knows the thing, but no one will listen to you.
Yep, very, very true. Scott, this has been very enjoyable for me. Thank you very much for your insights and your time.
Thanks, Rob.
Well, this will conclude the Feed Science Podcast for this episode. I'm Ron Hollenbach. Thank you for listening.
Thanks, Ron.